All right, we're going to continue on our journey in section 2.2. And we'll start off right here and taking a look at this function. Now, this right here, if you recall from day one, is intercept form. All right, so this right here, we'll go ahead and call intercept form. It says f of x is equal to a and then x minus p quantity times x minus 2 quantity. And what they're saying right here is that the value and location of p and q happen to be intercepts. So in this diagram that they share with you, they have one point is one of our intercepts, the other point is our second intercept. Okay. Now remember, if a parabola is symmetric and these 2 points right here, they are equidistant to the axis of symmetry, what is being displayed in this equation is x is equal to p plus q divided by 2, right? Because if I take two values and I divide it by 2, that will get me the exact middle. And that's how they came up with this equation, which is right here, they show you is your axis of symmetry equation. So it's something that you should memorize, and you really only need it for intercept form. Now, same thing in our third bullet, it says when a is greater than 1, it's going upwards, and when a is greater than 0, it's going upwards, and when a is less than 0, it's going downwards. Now, you have solved things like this in Algebra 1. You've done a lot of factoring in Algebra 1. Let's think about an equation like this. Y is equal to x squared plus 3x plus 2. All right, so now you're saying, well, this is in standard form. This is not even in intercept form. Well, it's factorable. This right here can factor into x plus 2 and x plus 1. And so you think about it. Well, okay, I factored it. How does that tell me the intercepts? If you remember this, if I want to find the x-intercepts, you set y equal to 0, and then you solve. So let me go ahead and do that. I'll set this y equal to 0, and I get x plus 2, and then x plus 1. And we'll set each of these binomials equal to 0 now, and then solve it out. Right, if I take x plus 2, set it equals 0, I get x is negative 2. I got x plus 1, set it equals 0, x is negative 1. And so now what I actually could do right here is first, let's figure out, we'll plot our intercepts. We have negative 2 right here and 1 right there. And then the only main concern now is, well, where exactly is my axis of symmetry? So what they're saying is we'll take these two values, our intercepts. Let me go ahead. I've got negative 2 plus negative 1 divided by 2. And so that'll get me negative 3 over 2, which is negative 1.5 or 1 1/2. So what they're saying is right here at negative 1.5, let's try this. And actually, no wonder why I'm pausing, because as I look at this, we have negative 2, negative 1 right here. I put the value of negative 1 in the wrong spot, and there is our axis of symmetry right here. So we have 2 points. To find that third point is the vertex. And remember, you need to take this negative 1.5, you could plug it into our equation, and figure out where the low point is. So if we go ahead and do that, we actually end up with y is equal to negative 0.25, which will be right here. And that is the basic idea of this parabola. Okay, using intercept form. Remember, intercepts, think of it as this. They're your x-intercepts, y-intercepts. What I'm trying to find right here are your x-intercepts. So let's go ahead and try a few more of these problems. Taking a look at number 4. So graph the function, label the x-intercepts and vertex and axis of symmetry. When it's in this type of form, you only need 3 points, the 2 intercepts and the vertex. So let's go ahead right here. If I have 2 binomials with x involved, then that should tell me that I have 2 x-intercepts. This 4, once again, it's your a value. It's greater than 1, so that should tell you it is a vertical stretch, and it's positive, it's going upwards. Okay, so let's go ahead now. I'll set f of x equal to 0, and then we'll go ahead and figure out our intercepts. So if I have x plus 4 equals 0, x is equal to negative 4. Take x minus 3, set equals 0, x is equal to positive 3. So let me plot these first points. 1, 2, 3, negative 4 right there. 1, 2, 3, positive 3. So we found our x-intercepts. Next up, I could find the axis of symmetry. Okay, remember, axis of symmetry for this instance is we'll take right here P and Q. So we'll have negative 4 plus 3, divide that by 2. So this right here ends up getting us, looks like negative 1 over 2, and we have negative 1/2. Now, so at negative 1/2, I'll go ahead right here, drop that down, there's your axis of symmetry. And it's x is equal to negative 1/2. Okay, don't forget, it's the equation of a line. Now, for our a value this time, it's a pretty big number, or it's bigger than before. It's 4, meaning that this function is going to be stretched out. So in order for us to figure out the rest of our problem, what I need to do, actually we don't even need to have a table, because remember we only need 3 points. The intercepts and the vertex. Let's go ahead, find what y is, and you're going to plug this in right here into the original equation and then solve it out. And what I end up with right here is y is equal to, looks like negative 49. And if we do intervals of 1, I mean, that'll be way off the grid, right? So we're going to have to do maybe intervals of, looks like maybe intervals of 10, right, for this to work out. And hopefully that makes sense to you, because remember, when a is greater than 1, we have a vertical stretch. So down right here, if we do intervals of 10, 20, 30, 40, negative 50, right down pretty close to the bottom right there is where you will have your point. And because we had to do some creative intervals to make this work out, it may not look like a vertical stretch, but hopefully you realize it is, because along the x-axis it's intervals of 1, but the y-axis we had intervals of 10. And there you have it. Okay, taking a look next up at number 5. So number 5 looks a little different because I only have one binomial. but I still have two intercepts. Okay. Remember, start off, if I want to find the x-intercepts, we set 0 or y to 0, or f of x. I've got negative 7x, and then x minus 6. First thing I do, I take negative 7x, I set it equals 0. Divide both sides by negative 7. 0 divided by negative 7 is 0. So that right there is one of my intercepts. The second one right here, x minus 6 equals 0, x is equal to 6. So I have right here at 0 and at 6. Let's go ahead and do intervals of 2 then to fit in. So this will be 2, 4, and 6 right there. When I take a look at my a value, we have negative 7. So that tells me that my parabola should be going downwards. Okay? It's also stretched out quite a bit. So we have to figure out, first off, where's our axis of symmetry? Okay, so let's do that next. And right here, axis of symmetry, I've got 0 plus 6, divide that by 2, and I end up with 3. So x is equal to 3, which makes sense, right? The halfway mark right here will be 3, and there is my axis of symmetry. Now we got to figure out where along this line is the rest of my vertex. So I know what x is. We plug things into the original equation to find y, right? So we got negative 7 times 3, and then we got ourselves 3 minus 6. And when you go ahead and plug all that stuff in, y is equal to 63. Once again, we want to plug that stuff in right here. It won't fit as is. Maybe if we did intervals of 20 this time, okay, that'll work out. So let's do intervals of 20. And so we have 20, 40, 60, and then 63 we can say is just slightly above there. And my function does something like this. All right, and we have now graphed things using the intercept form. The last question we'll look at, we put everything together right here, taking a look at number 6. Number 6 is a good problem that you may see on your test or your quiz. Okay, understanding, okay, what exactly is going on here with our baseball, or when you hit something that is similar to being a parabolic shape. Okay, so it says a softball player hits a ball whose path is modeled by f of x is equal to what you see there. Remember, our a value is negative. Okay, so that should kind of tell you automatically, all right, my parabola is going to be going downwards. Right? It's a reflection. So that's why it's going to go, and think about it, if you hit a ball, it goes up and then it's going to come back down. Right? There's no way you're going to hit a ball down and it comes back up and it be a parabola. So we continue on where x is the distance from home plate in feet and y is the height of the ball above the ground in feet. It says, what is the highest point this ball will reach? So that means if it's the highest point, we are talking about right here, we're talking about the maximum. And if the ball is hit the center field with an 8-foot fence located 410 feet above from home plate, will this hit a home run? Okay. What I care about first off is, well, what's the highest point? We've got to figure out, well, where is the vertex? The easiest way for us to do that is to find the axis of symmetry. Right? Because I'm trying to figure out, realistically, I'm trying to figure out, well, where is the highest point? Right? If you look at my diagram, the highest point will be right here at the maximum, which happens to be at the vertex, which is also where the axis of symmetry occurs. So we'll start off, we got negative b, or x is equal to, and then we'll put negative b, and we have b term is 0.2127 all over 2 times a, which we have negative 0.0005. All right, and there you go. We go ahead and simplify that. Use your calculator. I believe this is approximately 212.7. So what I figured out right here is that it is at 212.7 feet out, right? What that should tell us, or sorry, 212.7 feet. That is how far it is for the vertex, or at least the axis symmetry. How high it went, well, in order for us to figure out how high the ball is, we need to take this value of x and plug it into our function. Okay, so if we go ahead, we put f of 212.7 because that's supposed to be our value of x, right? This will help us figure out what y is. So let's go ahead right here. I changed things up a little bit because this is realistically how you set up your function in the most proper manner. So all I'm doing now is taking the original function and plugging things in to figure out my value of y, or f of 212.7. So when you plug this in right here, you should get f of 212.7. That right there is approximately 25.6 feet. So that's how high this ball is right here. The value of y, this point, is 25.6 feet. Now realistically, I don't think that's possible because that 25.6 feet is not very high up off the ground. So that's like a line drive. If for any of you that play baseball or softball will kind of figure. If it happens, you're freaking Superman. Like, you're smashing that ball and that cover probably should be ripping off at that rate. So anyways, this right here is the highest. We have found the maximum. Now it says if the ball was hit to center field, which has an 8-foot fence, at 410 feet from the plate, was this a home run? So think about it. How am I going to figure that out? In order for us to figure that out, right here in my equation, remember we figured out what f is, or our value of y, at 212.7. So for the last thing right here, if I want to figure out where is it at 410 feet, how about we change our value of x to 410? And so you'll do the same thing, except this time we'll put 410 feet into our function, and then see what we get. If this value at 410 feet is greater than 8 foot, right? If we get a number right here greater than 8, then it's going to be able to clear the fence. If it's less than 8, you're not going to be able to clear the fence, and you're not going to be able to hit a home run. So if you plug that in, maybe it'll give you a few moments. You could pause it, try calculating it out, seeing if you can get the correct calculation. Because remember, half the battle for a lot of you is making sure that you can plug things into the calculator correctly. At x at 410 feet, it's about 6.2 feet high. That's where the ball is. Is it a home run? No. It needs to be 8 feet or higher. Or actually, probably it needs to be higher than 8 feet for it to clear it, right? So, in the end, it did not. All right, it was short. It needs to be above 8 feet, which it is not, and that would be a good explanation there. All right, we have now finished 2.2.